example 4 we are taking now. Here we have triangle ABC. Point D is on the side of AC. BP is perpendicular to AC. That means this is 90 degree, or we can take it as a height. AC 16. That means we will take AC, the entire thing, as 16. DC is 9. Now you have 2 points in between. We have P here and D here, of which a part of it we know DC is 9. So we don't know AD. So how will you find AD? Because these points are collinear in a straight line. So if we have to find AD, what do? A formula. We'll use AD plus DC will give us AC. That means when we add the small from here to here and from D to C, the entire thing will be AC. So AD is how much? We don't know. Okay, AD we don't know, so we will write AD as it is. How much is DC? DC is 9. And how much is AC? AC is 16. So this is given. AC is 16. Now AD is equal to, we'll take 9 this side. So plus 9 will become minus 9. So AD is equal to 16 minus 9, which is 7. So now we have got, we will write in cape here, AD is equal to 7. Okay, here we have got 7 and here this thing will be 7. Okay, and now we'll try to find the ratios which is required. What are the ratios which is required? Area of triangle ABD upon area of triangle ABC. Second ratio which we have to find is area of triangle BDC upon ABC. And third one is area of triangle ABD upon BDC. So before we start finding, one point which is to be noted is this. Point D is on this side and B is common. Now remember, we have learned that when the vertex is common for all the triangles, then the height are common. So everywhere I have drawn this triangle separately. We have got ABD, we have got ABC, and we have got BDC. These three triangles are there, whose ratios we have to find. So we can find that all of them have the common vertex. So when we have the common vertex with the base which is collinear, then they have the equal height. So this triangle will have equal height. So which is the height here? Height is BP. Okay, height is BP. So everywhere height will be BP. Okay, now let's try to find the first area, which is area of triangle ABD. We are going to find the first ratio, area of triangle ABD upon area of triangle ABC. Now which formula will we use? We will use the formula A1 upon A2 is equal to B1 upon B2. We are not taking H1 because height is common. So we have learned that when the heights are common, then the ratio are corresponding to their bases. Now ABD, what is the base? ABD, this is the first triangle. The base is DA. And ABC. ABC. Here is A, B and C. Okay, the base is AC. How much is AC? AC is given as 16. Okay, so there is no problem. DA we have found, or AD we have found as 7. And AC is given as 16. So the first ratio will be 7 upon 16. We have found the first ratio using the formula A1 upon A2 is equal to B1 upon B2. Now the second ratio we have to find, that is area of triangle. This was the first one. Second one, area of triangle BDC upon area of triangle ABC. Now in BDC, this is a triangle here, BDC. What is the base? Base is CD or DC. You can name it as CD or DC. We'll take it as DC. Since it is given DC, we'll take it as DC. And ABC. What is the base? ABC. This is the triangle. ABC. What is the base? CA. Okay. Or AC. We have already taken it here, right? So DC was how much? DC is 9. It's given in the question. And AC is 16. The second ratio we have found. Area of triangle BDC upon area of triangle ABC is equal to 9 upon 16. And the third triangle, area of triangle ABD upon, now remember it's just repetition. Here also we have got area of triangle ABD upon area of triangle BDC. Here we have BDC. Okay, so what is the base of ABD? ABD was this first triangle. What is the base? Base is DA. We have already taken here ABD and base is DA. And BDC. BDC we have taken here and the base is DC. Okay, so BDC we have here and the base is here, so this one DC. And now what is the value of DA? DA we have already done, it is 7. And DC we have already done 9. Okay, so we have found all the ratios which is required in the question. Okay, so now let's do it very neatly. The entire thing which I have explained, I am going to show it screen by screen so that you all understand. The first one is B is a common vertex of all the triangles, right? Point A, P, D and C, all these points are collinear. When they are collinear, distance from point B to the base is the same. So we have found that their height will be the same. Height of all the triangles will be the same. Therefore, we'll take the formula A1 upon A2 is equal to B1 upon B2. Okay. Now, since the points are collinear, therefore DC is given as 9, AC is given as 16, AD plus DC is equal to AC. AD we don't know, so we'll write AD as it is. DC is 9, it is given, and AC is 16, that is also given in the question. Now, what will be AD then? AD will be 16 minus 9. We bring 9 this side. So, plus 9 will become minus 9. So, AD is equal to 7. In the first part of the question we have solved, that is area of triangle ABD upon area of triangle ABC. So, ABD is here. Now, height we are not taking, as I have told you that height is common. So, we are taking the formula A1 upon A2 is equal to B1 upon B2. Okay. Now, what is B1 here? B1 is BD. B1 is AD. Here. It is here. B1 is AD and AD is 7. Next is triangle ABC. ABC, the big one, and the base is this part, the entire thing, AC 16. So, what is B1? AD and B2 is AC. AD is how much? 7 and AC is how much? 16. Therefore, we got the ratio, the answer as, final answer you will write like this. Area of triangle ABD is to area of triangle ABC is equal to 7 is to 16. This is the first part of the fourth example. And the second part is this. We are going to take this triangle BDC upon ABC. Now BDC, base is DC, base is here 9. See here 9, base is here. So the straight line is that this is the base and this is the base of this small triangle. Okay. Now, so base is 9. It is given here. Here also I've written 9. So base is DC, which is 9. And in triangle ABC, base is AC. This entire thing, big one. We did it in the previous part also. So AC 16. So now once again, what is the formula? A1 upon A2 is equal to B1 upon B2. So area of triangle BDC upon area of triangle ABC is equal to DC upon AC, which is 9 upon 16. We have got it here 9 and we have got 16, and 9 is B1, 16 is B2. So final answer is this, which you can also write like area of triangle BDC. Actually, we are finding the ratios. Ratio of area of triangle BDC is to area of triangle ABC is equal to 9 is to 16. Now we go to the third part and the final part of this fourth example. Then next part, it was ABD upon BDC. Now ABD, again ABD we have done in the previous examples. AD is 7, base is AD, which is 7. See, AD is here, okay. Actually we are taking the base from this side. Though the figure is actually slanting, it's not given same way. If you look like this, okay, we will have the base here AC, and then we will have all these points here DC, D here. Okay, so we are taking, and B is common here. So ABD is here. So base is AD, and BDC base is DC. Okay, so we have written here AD is 7, DC is 9. Again, formula A1 upon A2 is equal to B1 upon B2. And what is B1 in area of triangle ABD? It is AD, right? You got it here. This is B1, this is B2, this is 7, and this is 9. Okay, so AD upon DC is equal to 7 upon 9. So your final answer will be ratio of area of triangle ABD upon area of triangle, not upon, is to area of triangle BDC is equal to 7 upon 9, which you can also write as area of triangle ABD is to area of triangle BDC is equal to 7 is to 9. So with this we come to the end of the solved examples. Having understood the concept of similarities, ratio of areas of triangles, and the solved examples given before the practice set, I'm sure you'll find the practice set 1.1 very easy. So watch the next video to understand the first sum of practice set 1.1. Children, if you have not watched the earlier videos, please watch the videos, the link of which I will give in the description. Only if you understand the earlier lectures, then you will understand or find it easy to solve the practice set. So kindly watch the earlier videos. Thank you children, and God bless you.